Hi there. For our last video on anti-differentiating, I'm just going to look at a few reversals, and there's no real good name for these, but where it's at university you're going to study integration by parts, and this is like an introduction to that. And some people are very good at these. They can pick what is something going to look like when they anti-differentiate it, and they can sort of guess what the answer might be, and they use this reversal procedure. And so I'm just going to start and show some examples because it's very hard to explain what I'm about to do. Alright, so let's just go straight into an example, and it will look like something like this. It'll be something like differentiate, let's just do x e to the power 3x or something like that, and hence find the integral of x e to the 3x. Okay, so let's just have a look at this before I start. What we're asked to do is to differentiate this, and then what we're going to end up with is an answer. And then what we'll do is use that to go backwards. And what we're saying is that if you were asked to find the integral of x to e to the 3x, then someone might be guessing, well, it's going to maybe look something like this. It's going to look something like x e to the 3x, because when you integrate e, you're going to get e back again. And so they're just sort of guessing it might look something like this. So what we're saying is, okay, let's guess it looks like this. Differentiate it, see how it ends up, and then figure out the rest. I'll show you a bit more what I mean. You will never have to guess what it will look like in this course, but in future years it's a good skill to have, to sort of be able to guess what it looks like. Don't worry about it for this year. So therefore, if we just let y be equal to x e to the 3x, and we've got product rule here, so the derivative of that product rule is equal to the derivative of the first, which is 1, times the second, so e to the 3x, plus just x times the derivative of the second, so that's e to the 3x times by 3. Okay, so there we've got the derivative of y is equal to that. So what we've done is we've gone in this direction. The derivative is that. What we want to say now is that, okay, well, if the derivative of y is equal to that, then that means the integral of all of this is equal to that. Okay, we're just going in the opposite direction now. So just let me write that down so you can see what I mean. So therefore, the integral of this here, e to the 3x plus 3x e to the 3x dx is equal to, in other words, going in the opposite direction, because we've shown that this is the derivative of that, so that means the integral of that is just equal to this, equals x e to the 3x plus some constant c. Okay, hopefully you can see what I've done there. We've just gone in the absolute opposite direction. We've gone, okay, so the integral of this is equal to this. Cool. So what we can do now is we're asked to find the integral of x e to the 3x, which is basically this here. That's, oh, I thought I changed colours. Which is this here. So that's what we're trying to find. We're trying to find the integral of that. And so what we can do is we can separate these integrals. We're allowed to do that, and then move things onto this side so we can get an answer. So let's do that. So therefore, let's break these integrals up. We've got integral of e to the 3x dx. We're allowed to split up integrals into their little pieces. You know that already sort of intuitively, but probably haven't been explained that. Plus the integral of 3x e to the 3x dx, so splitting up, equals x e to the 3x plus c. Okay, so what we're going to do now is just solve this equation, because what we want to know is this. Well, we want to know a third of that, but anyway, we want to solve for this. So what we're going to do is move everything over. So therefore, I'll bring the 3 out the front. Therefore, the integral of 3x e to the 3x dx is equal to x e to the 3x. Then we're going to move this onto the other side. So minus the integral of e to the 3x dx plus c on the end there. Okay, so therefore, so that equals, that remains x e to the 3x. And what is the integral of this here? And so integral of that, so it's minus e to the 3x remains, but we're going to have 1/3 come out the front. So that's the integral of that. Now we're going to add a constant. There's going to be a d there plus c. We've got a constant from this integration. We've got another constant from this integration up here. So I've got two sort of constants, two different constants sitting there. Okay, so that's, didn't write that in, but don't really need to. X is equal to that. We're asked to find the integral of x e to the 3x. So I just need to divide by 3 and I'll have my answer. So therefore, the integral of x e to the 3x dx is equal to, and I'm just going to divide everything by 3 to get my answer. So that's 1/3 x e to the 3x minus 1/9 e to the 3x plus, I'll just call it, no, e's are bad, plus k. Now I've just called this another thing, and I'll just say I've just introduced where k is equal to c plus d. In other words, I'm just bringing in another constant. It's just some other constant, doesn't matter. It's d plus c, but we're just bringing in that. So there we go. And that's your answer. We've integrated that successfully. How did we integrate that? We guessed, well, you don't need to do it, but you're told to differentiate this and then to work around to figure out, move things around, solve for the particular integral that you're looking at. Okay, so I'll just do one more example of that. I'll show you a similar thing. Another one. Okay, so differentiate this and hence find the integral of x sine x dx. Okay, so let's go ahead and differentiate. So dy by dx, in general these are product rule type questions, okay? Dy dx, differentiate 3x and you just get 3. Cos x plus, leave the 3x and then differentiate cos x and you get negative sine x. So it'll be minus there. Okay, so minus 3x sine x. Good, so we've got that. What this means is that the integral of this is equal to y, okay? So, so there we go. So we've got the integral of 3 cos x minus 3x sine x dx. So the integral of all of that is equal to y, which is 3x cos x. Okay, so there's our sort of key piece of information that we've gotten there. Okay, right, so from here, what do we do? What are we trying to solve for? Let's have a look. We want the integral of x sine x, which is basically this piece in here. That's what we want. And so we're just going to have to solve for this. So we'll break this integral up into its pieces and then move it across. Okay, so I'm going to do that in one step this time because you've seen it before. So that means the integral of negative 3x sine x dx is equal to, so is equal to 3x cos x, and I'm going to move this thing over to the other side. So it'll be minus the integral of 3 cos x dx. Okay, well good. So all I've done is move some stuff across to the other side. Fantastic. Let's bring this negative 3 out the front of the sign. So we've just got x sine x, because that's what we want it to be equal to. Is equal to 3x cos... Oh, and I forgot my plus c up here. No one yelled out and told me. Plus c. And I'll be a bit more proper. I'll call it plus c1 this time, okay? So that should be down here as well. Plus c1. Sorry about that. Negative 3 is equal to 3. So get minus. Let's integrate that. So it'll be 3. What's the integral of cos x? Sine x plus c1. And because we just integrated again, we're going to get another constant c2. And there we go. Fantastic. So therefore, now I want the integral of x sine x. And so I just need to divide all this by negative 3. So that's equal to negative x cos x, divide that by negative 3, plus sine x plus c, where c equals c1 plus c2, and we divide by negative 3. So just to be, oh, that didn't work well, negative 3. You can see why we use just, if you use C1s and C2s, then you can just have C in your final answer. But it really doesn't matter what that letter is there, you can use any for a numeral. Okay? So that's the procedure. Take the derivative and then rearrange the integrals to get what you want. And that's what you'll find out is that that's integration by parts in future years at uni. You don't need to worry about that yet. You just need to be able to know how to do that little reversal of the integral. And that's the end of integral calculus. Well done. See you soon.